Okay, here's a wild one for you. What if the Earth just stopped spinning?
Whoa.
Yeah, just like instantly, you're maybe walking down the street, pouring coffee, whatever, and bam, full stop.
That sounds like something straight out of a really bad sci-fi movie.
Totally. But what if we actually looked at the science behind it,
Mhm.
using real stuff from like NASA geophysicists?
Okay, so grounded in actual physics, not just speculation.
Exactly. That's the mission for this deep dive. Forget the Hollywood version for a sec and explore what fundamental forces are at play and, well, what kind of utter chaos would actually unfold.
It's a fascinating thought experiment, definitely, because that spin is so fundamental.
Right. So you ready to kind of tilt reality a bit?
Let's do it. It's quite something to wrap your head around, the idea of something so constant just ceasing
Yeah.
and the immediate consequence, especially thinking about inertia. It's almost unimaginable.
Okay, inertia. Let's start there. We're spinning super fast, right? Like over 1,000 miles an hour at the equator.
Yeah, roughly 1,670 kilometers per hour, which is well over 1,000 miles per hour. Supersonic, basically.
So if that stops,
Yeah.
dead stop,
Yeah.
does everything just fly off,
Yeah.
like into space?
Not quite into space. Gravity's still holding things down, thankfully. But think about being on a merry-go-round that slams on its brakes.
Yeah, you get thrown, right?
Exactly. Now, picture that on a planetary scale. Anything not literally part of the Earth's bedrock, buildings, trees, cars, people, water, it all keeps going eastward at that incredible speed.
Oh, man. So just sheared off.
Yeah.
Buildings just ripped from their foundations.
Pretty much instantaneous, catastrophic destruction, bridges collapsing, structures disintegrating. The forces involved are, well, staggering.
We're talking vaporization level destruction for some things, I imagine. And what about the oceans? They're definitely not bolted down.
Precisely. The oceans would just keep surging eastward. You'd have these unimaginable tsunamis, just walls of water scouring across continents, nothing like we've ever conceived of.
Okay, wow. And the air? The atmosphere is spinning with us too, isn't it?
It is. So if the solid Earth stops, the atmosphere doesn't, not immediately anyway, it keeps moving at, potentially over 1,000 miles per hour.
That sounds like wind like nothing else.
Yeah. Think global supersonic winds. Sources like NASA talk about winds far stronger than any hurricane, everywhere, all at once. The friction alone would cause immense heating and scouring.
Just the wind itself would be an extinction level event, probably.
Almost certainly, yeah. The sheer destructive power is hard to overstate.
Okay, so that's the first few minutes. Utter chaos.
Wow.
Assuming anything is left standing, what happens next?
Yeah.
After the initial shock settles?
Well, the longer-term effects really stem from the fact that the Earth is no longer rotating, and one of the biggest immediate casualties of that is the Coriolis effect.
Ah, the Coriolis effect.
Oh,
Yeah, that's the thing that makes storms spin and influences ocean currents, right?
Exactly right. It's an effect of the Earth's rotation that deflects moving things, like air and water, to the right in the northern hemisphere and left in the southern. It governs our global wind patterns, jet streams, trade winds, all of it.
So without rotation, no Coriolis effect.
Correct. Which means those established wind systems just collapse. You lose the predictable patterns. Weather becomes completely chaotic, unpredictable on a global scale. Forget forecasts.
Constant atmospheric turmoil, basically. And you mentioned earlier the oceans. There's another effect related to the Earth's shape.
Yes, exactly. The Earth isn't a perfect sphere, it bulges at the equator.
Right, like spinning pizza dough gets flatter.
Kind of, yeah. That rotation creates an outward centrifugal force, strongest at the equator, which causes the planet to be slightly wider there. An oblate spheroid is the technical term.
Okay, so if the spinning stops,
That centrifugal force vanishes. Gravity then pulls the Earth back into a more perfect spherical shape. The equatorial bulge relaxes
and that affects the water.
massively. All the water that was sort of piled up around the equator by that bulge would migrate towards the poles. You'd see sea levels drop catastrophically near the equator.
Turning tropics into deserts, maybe.
Potentially, yes. And conversely, huge amounts of water would flood the higher latitudes. Think places like Canada, Siberia, inundated. It would fundamentally reshape continents.
Wow, the knock-on effects are just mind-boggling. One change triggers all this. And it gets worse, doesn't it? What about the magnetic field?
Yeah, that's another big one. Earth's rotation is a key ingredient in generating our magnetic field. The movement of molten iron in the Earth's outer core, driven partly by the planet's spin and partly by convection, creates electrical currents.
The geodynamo.
Exactly, the geodynamo. If the rotation stops, that dynamo process would weaken dramatically, likely sputtering out over time. The magnetic field would collapse.
And that field is our shield, isn't it, against, like, solar radiation?
It's absolutely crucial. It deflects most of the harmful charged particles from the sun, the solar wind, and cosmic rays. Without it, or with a much weaker field, the surface of the Earth would be bombarded with dangerous levels of radiation.
So on top of the winds, the tsunamis, the climate chaos, we'd also be getting fried by radiation.
It would be a very hostile environment for life as we know it, certainly. And there's another long-term effect, looking at planets like Mars, which lost its global field.
Right. Mars has a very thin atmosphere now.
Yeah, the thinking is that without a protective magnetic field, the solar wind can, over millions of years, actually strip away a planet's atmosphere. So eventually, Earth could lose its air and water to space.
Okay, this is painting an incredibly bleak picture. Is there any scenario where humans could possibly survive this sudden stop?
With a sudden instantaneous stop like we've been discussing, the initial inertial forces, the winds, the tsunamis, it's almost impossible to imagine widespread survival. The destruction would just be too immense, too immediate.
But you hear people talk about maybe if it's slowed down gradually.
Well, yes. If the Earth slowed its rotation over, say, millions of years, that's a completely different scenario. Ecosystems and potentially even life could adapt over those vast timescales. But a sudden halt, that's pure catastrophe.
Any potential survivors from that initial shock? Where would they even be? You mentioned the poles earlier.
Right. Near the poles, the actual speed of rotation is much, much lower than at the equator. Think of the center point of that spinning merry-go-round again.
Less speed, so less inertia, less being thrown sideways.
Exactly. The initial devastation might be less extreme right near the geographic poles, but less extreme is relative here. Survivors would still face incredible challenges.
Like what? Assuming they survive the initial jolt.
Well, you'd have a 6-month day followed by a 6-month night. Extreme temperature swings between scorching sunlight and unimaginable cold. The chaotic weather systems we mentioned. The radiation exposure. The flooded coastlines and reshaped continents.
Yeah, survival seems like a very optimistic word in that context.
It would be an existence almost unrecognizable to us now. A fundamentally different and vastly more hostile planet.
This whole thought experiment, as kind of terrifying as it is, really hammers home how interconnected everything is.
It really does. We think of the Earth spinning as just normal, background noise. But it's fundamental to gravity as we experience it, to our weather, day and night, time itself, and ultimately the conditions that allow complex life to even exist.
It's like you pull one thread, albeit a massive thread, and the entire tapestry unravels.
That's a great way to put it. It shows how a single change in a complex system can cascade into, well, global devastation in this hypothetical case.
And exploring these what-ifs, even the impossible ones, helps us appreciate the balance.
Right, absolutely. It deepens our understanding of the fundamental physics governing our planet and, frankly, fosters a real appreciation for the conditions we currently enjoy. It fuels that scientific curiosity about how things work.
Okay, so let's try and sum up this slightly terrifying journey. If Earth slams on the brakes, instant global destruction from inertia, supersonic winds, world-engulfing tsunamis.
Check. Then, longer term, total weather chaos as the Coriolis effect vanishes.
Continents reshape as the equatorial bulge flattens and water redistributes, flooding poles, drying tropics.
Right. And our protective magnetic shield collapses, leading to lethal radiation levels and potential atmospheric stripping over time.
Survival chances. Pretty much zero for most life, maybe a sliver of hope near the poles, but facing an unbelievably harsh new reality.
Yeah, a grim picture. It just underscores how absolutely critical that simple rotation is for, well, everything that makes Earth habitable.
It really makes you think, doesn't it? What other fundamental constants of our planet do we take for granted, and what might happen if they were suddenly altered? Something to ponder long after this stops spinning in your headphones.
Definitely food for thought. A reminder of the intricate dance of forces that makes our home planet work.